The first type of RF resonant accelerators ever invented was a cyclotron and another version thereof, the isochronous cyclotron, which was built later. The idea belonged to Ernest Lawrence, after he had seen Ralph Widerow's article on a linear resonant accelerator. The article was written in German, and although Lawrence couldn't understand German, by means of pictures and formulas, he managed to understand the synchronism principle. And he thought, why not pass a particle through the same gap by rotating it in the magnetic field? The first cyclotron that he built looked like an ordinary transformer. It had been created through a grant from the US government amounting to $1,000. Here you can see a picture of a more serious accelerator used for experiments in high-energy physics. It was launched in 1930 with the participation of Lawrence's doctoral student, Livingston. The operation principle of a cyclotron is rather simple if one describes it using basic pictures. There is an iron core with a vacuum chamber between its polar tips. The core has a coil, which excites a magnetic field. Inside the vacuum chamber, there are RF electrodes performing the beam acceleration. The RF electrodes remind one of a tin can cut in half. They resemble an English letter D, and that is why they are called duons or D electrodes. An alternating RF field is applied to these electrodes. At the center of the magnet, there is the ion source. The ions, through their interaction with the electric field of the duons, increase in energy. The orbit radius rises. The orbit looks like a spiral, turning from the accelerator center to its periphery. When the particles reach the magnet borders, they get extracted from the accelerator with the use of a special deflector, and then utilized for further experiments. It was the cyclotron that was used as one of the first facilities at our institute. Under the guidance of Georgy Flerov at the future Flerov Laboratory of Nuclear Reactions, the first specialized heavy ion cyclotron was created. Today, the construction of a new cyclotron complex is being finalized. The complex will consist of 4 cyclotrons: a specialized cyclotron for the synthesis of superheavy elements, a cyclotron for the study of heavy and superheavy nuclei, a cyclotron for the study of light exotic nuclei, and another cyclotron for applied research. Besides that, the complex will include a laboratory for the research in nano-objects obtained with the help of heavy particle beams. The Flerov Laboratory of Nuclear Reactions and its program on the heavy ion cyclotron development have, to a great extent, determined the international authority of our institute. Currently, the International Committee has prioritized the discovery of numerous new elements for Mendeleev's periodic table. The first among them was named dubnium. It's the 105th element. Most recently, new names have been given to 2 other elements. The 114th element has been named flerovium in honor of the founder of the lab, a member of the USSR Academy of Sciences, Georgy Flerov, and the 118th element has been named after the lab's current scientific leader, Yuri Oganessian.